So whenever we do diagnostics today, there are some key questions that we have to ask ourselves. For example, how do you do diagnostics today? What's the process that you have? And what tools and processes do you have in place to do diagnostics today in your environment? And the second question really is, how do you manage your applications and services today? And again, the same type of questions. What process do you have in place to manage these applications and services? And then once we have answers for those questions, then we need to re-ask those questions in context of the cloud. And what challenges do we have with applying diagnostics in the cloud? So then this begs the question, how on earth do we do any debugging in Azure? And their answer really is, you can't. It's just not allowed for several reasons. First, your instances can be moved around a lot, and they're going to be moved around as needed, and really for the support and reliability reasons. And as these get moved around, this could easily disrupt your debugging sessions. And second, there's the issue of directly connecting to a machine with a specific IP address, which you obviously can't do, since each server is protected and hidden behind firewalls, load balancers, and really those guys from Halo. So you really can't do any type of debugging. And so when you're talking about debugging, you're talking about issues that pertain to the cloud. You've got a lot of instances. These instances move around a lot. You're also dealing with a lot of data, and that data can move around a lot depending on what components you're working with. And then you really have no remote tools to provide that type and level of debugging. So if you can't debug, what options are there and what can you do? Well, the answer to this is simple. It's called the Windows Azure Diagnostics System, and it's a nifty little process called the Mon Agent Host. The whole goal of the diagnostic system is to let you access all of the data and diagnostic systems that you are used to and bring it all together in a single cohesive set of data, making it much easier to work with. The Mon Agent Host process is simply an agent that runs on each role instance of your application, and its sole job is to collect the data that you want to a local buffer and then transfer that data to your Azure storage account when you want it. And this host is started automatically by default, and it's wired up in the app.config and web.config files. The great thing about the agent is that it can tap into all of the normal diagnostic engines you normally use, such as trace logs, IIS logs, performance counters, and even Windows event logs. So since this is using an Azure storage account, you obviously need to define a storage account connection string when working with the Mon Agent Host. So let's take a high-level look on how the agent works. The agent runs on each role instance of your application and is started by default on the onStart method of your role. The agent collects the data you want and it stores it in a local buffer, and this buffer is a defined 4 GB buffer for diagnostics data. As the buffer fills up, the oldest data will be aged out. It is up to the user to initiate the transfer of data to the storage account, but this transfer can also be scheduled if you need it to be. Now, we talked briefly about the types of data that can be collected by the agent, but this is the entire list of what data the agent can collect, whether or not they are collected by default, and where the information is stored. Now, notice that by default, trace logs, IIS logs, and the infrastructure logs are enabled by default, and the others are not, but can be enabled via the configuration. Now, even though the agent is installed, you need to load it so that you can use it. And loading it is as simple as specifying that you want to use it in the service definition file. Now, a connection string is also needed, but Visual Studio is pretty smart. As soon as you add the import section in the service definition file, a connection string is automatically added to the service configuration file. All that you need to do is open the service configuration file and add the text for the value property, because it leaves that blank, so you can specify whether you are using local storage for testing or an HTTPS value when you move the application into production. Now, it's also possible to write to the trace file, and this is possible simply by using the trace class of the system.diagnostics namespace. As shown in this example here, you can use the trace class to write your own tracing information to the trace output. For example, on the page load, we're writing that the page load is loaded on and then applying a date. Then we're adding a critical entry stating that it has failed to connect to the database. So this simply uses the trace class of the System Diagnostics namespace to easily write your own trace information to the trace file. So now that you have your diagnostics going and all is going well, what happens if all of a sudden you find yourself needing to make a change? And then if you need to make that change, how do you do that? And you have a couple options, and they both involve getting either the default configuration or the configuration you are currently running, then making the necessary changes, and then uploading the new config, and then restarting the diagnostics with a new configuration. Now, changing the configuration can take place from a couple of places, and depending on where you make that change will determine what is affected. You can change a configuration from within an instance. That only affects the specific instance, but that also allows you to start that agent immediately. The other option is to change the central configuration file from outside of any instance, meaning for all roles. And in this scenario, the agent notices the change and reloads the new configuration and applies the change to all the instances of that role. So let's take a look on how that works. First, the user downloads the configuration file and makes the necessary changes. And then the user makes those changes and uploads the new configuration file. The agent, via its polling interval, notices the change in the configuration file, and then the agent applies those changes to all the instances of that role. We talked about pulling down the current configuration file, and here's an example on how to do that. The first thing we do is create a cloud storage account that points to the storage account that's going to be used for the diagnostics data. Then we create an instance of the create role instance diagnostic manager off of that, passing in the instance info. So in this case, the deployment ID, the role name, and the role instance ID. And then lastly, we then call the get current configuration. That then downloads the current configuration file, and at that point, we can start making changes to the configuration file. So once we've downloaded the configuration file, making changes really isn't rocket science as demonstrated here. So first, in this example, we create a perf counter config object. We then add the counter specifier, which in this case is a processor time and the time span in seconds. We then change the sample rate. We add the config object to the data source collection, and then we adjust the schedule transfer period. And that's the last statement down there. How often are we going to schedule the transfer period from the data from the buffer to our storage account? Now, once we've made those changes, how do we commit those changes? Well, again, it's not rocket science. Committing it really is just a piece of cake. We simply commit the change by passing in the config object from above. All done. So one line of code, we've just submitted and committed our configuration changes back up to our instances. Now, we talked earlier about the ability to transfer log information to Azure Storage, and one of the things that you can do is to apply filters as you transfer that data. Now, the log filters don't filter what data is collected, rather it filters the data that is transferred. You can then filter data that's being transferred simply by setting the log level filter property, such as in this example, which is only filtering on errors. So in other words, transfer only log data that are error specific and transfer those from our buffer to our storage. Now that we've transferred our data, how do we look at that data? Because our data is going to be in several locations. It could be in Azure Storage Blobs, it could be in Azure Storage Tables, it could be in a number of places based on that table we saw earlier. So how do we view it? Well, we have several options. We could write our own tool to pull the data from Azure Storage and manipulate that data and make it real pretty. Or we could use a nifty little tool from a company called Cerebrata called the Azure Diagnostics Manager. This tool allows you to view the data from the specific type of logging information you've collected, such as trace logs, event viewer logs, and even performance counters. Now, Sarah Broada's Azure Diagnostics Manager also allows you to view the data in a reporting type of mechanism to allow you to see a historical trend and do some level of metrics to see what has happened over time. So it allows you to present the data in a more reporting fashion. One of the key pieces of functionality of this tool is also the ability to configure your counters remotely. So you don't have to go through code. You can actually, through this tool, through their Azure Diagnostics Manager tool, to configure the counters remotely and apply them from here without having to use the API and write any code. Now, we talked about the ability to schedule the transfers of data from the buffer to Azure Storage. And so how do we do this? And really, you have a lot of flexibility and control over how this is done. You can assign each source its own transfer schedule, and the Diagnostics Manager ensures that the appropriate data is transferred at the right time. If you want to simply disable a specific transfer, all you need to do is set the transfer interval to a value of 0, and it won't transfer until you change that value back to a value greater than 1. For example, here, performance counter log is scheduled to be transferred each day, while the diagnostic infrastructure log is disabled since the interval is set to 0. Now, there may be times when you want a more granular control over when the transfers happen, so the Diagnostics Manager allows for an on-demand transfer of data. This comes in handy when you want to respond to specific events, and these events are handled like an external configuration change. And really, any on-demand requests are handled asynchronously. So once a request is made, a request ID is returned so that you can track the progress and the status of the request. And if you need to, you can actually take the success report and report that success to a queue. So here's how you do that. The first thing we do is define the type of data buffer that we want to transfer. We set our transfer options, which is in this case an on-demand transfer option. We define when we want to do it. Right now, this is now. And then we loop through all of the instances that we want to transfer, and we call the begin on-demand transfer method to actually begin the transfer. Okay, let's shift gears a little bit and talk about service management and how we can have a more granular control over managing our services. From a service management standpoint, there may be times when we want a more programmatic ability within our code to do a lot of things that the management portal does. We've spent a lot of time in the Windows Azure Management Portal, and we know what capability it has, but there may be times when we want to be able to do a lot of those things programmatically and not through the Management Portal. So the solution to this is really the Service Management API. This allows us to do almost anything that the portal can do. And this API provides programmatic access to much of the functionality through the Management Portal, and we can use the Service Management API to manage our storage accounts and hosted services, our service deployments, and even our affinity groups. There are some limitations to this. For example, we can't get to any of the billing data, we can't create any subscriptions, we can't create a storage or compute service, and we cannot deploy any management certificates. So there are some limitations, but we can do almost everything the portal can do. Anytime you're working with the Service Management API, all of the operations must be performed over SSL, and they need to be mutually authenticated using X509 certificates. Now, you can register up to 5 certificates, and you can revoke these certificates at any time. These certificates can also be self-signed, and simply all you do is upload the certificate through the portal. Now, the key here is that the management service may be accessed from within a service running in Windows Azure, or you can actually access that directly over the internet from any application that can send an HTTPS request and receive an HTTPS response. Let's spend a few minutes and talk about service deployment. We've built our application, we've finished our development, and we've done all our testing, and now we want to deploy our application. How do we deploy that application? And we do have several scenarios. We can use Visual Studio. to delete and create our deployment, and we've seen several examples of this. We can use the virtual IP, or what's called the VIP swap, to make these changes. So if we deploy to production and then deploy to staging, we can use the VIP swap to make these changes and redeploy. And the great thing about this is that the service model updates don't matter. So if we're updating our service model, that doesn't matter. We can deploy either through Visual Studio or the portal, and the service model doesn't matter. We can do VIP swaps, which means we can bring up another environment in staging and swap that with production. But if we're doing that, we need to keep in mind the type of endpoints that we have, because those matter. Have we added an internal or external endpoint? And what has that done? And how does that affect our application? So again, we need to keep in mind what endpoints we've made when we're updating an application. Now we can also do in-place upgrades. This is really a rolling upgrade across the roles. It's really most restrictive on changes, so restrictive on size and endpoints and roles and things like that. And we can also do a web deploy, meaning we can do a web deploy through the management portal. Now we just talked about the two different types of deployment environments. We've got a production environment and we have a staging environment. So we really have two environments to choose from, and they're really almost identical. The key difference is if you're deploying to production and we create our service called appdevdemo.cloudapp.net, then that's the service name it's going to be, and that's how we'll access that application. But if we deploy to the staging, then we're actually going to get a GUID ID, or what's called a deployment ID, for our staging environment. And that way we can have a production environment and a staging environment that's not stepping on each other via the name. And the staging environment is going to be the deployment ID.cloudapp.net. Deployment ID.cloudapp.net, where the deployment ID is really a GUID. Now the great thing is what the management portal actually allows you to do is do a VIP swap between them, and VIP means virtual IP. So if we have our production environment running and we've uploaded and tested our updated application and that's running in staging, we can actually do a VIP swap and swap those and move our staging into production. Now when we're talking about deploying applications, whether either to production or staging, we need to be cognizant of what's running. We need to be cognizant of what's running and how many instances of those applications are running. We can't just deploy and then forget about it. So we always need to keep in mind of what we have running. And so how do we know what's running? How do we know how many instances are running? And we can't just deploy and forget about it. So we actually need something to protect ourselves from our own stupidity a lot of times. So there's actually a nice utility out on CodePlex called the Gray Box application. And it's out on graybox.codeplex.com. And it's an open source project. And what it does is it reminds you if you have apps running, and it helps you stop them if you need to stop them. And the key thing is that it really avoids overrun of an MSDN allocation. So if you've got an MSDN account and you've deployed a lot of applications and a lot of databases, and you forgot about those, these will notify you that, hey, you have these deployed. Don't forget about them, and it'll notify you that you're approaching your allocated usage and space, and to do something about it. So the way it works is the Graybox application, once installed, puts a little icon on our task tray that either shows a blue box or a gray box. So really, what do the colors mean? Well, you can remember it this way. It's a quick little rhyme that says, if the box is gray, you're okay. If the box is blue, a bill is due. So a quick little rhyme to help you understand that if you see this icon and it's gray, you're fine. If it's blue, you've got money to pay. You've gone over your allocated resources. So through this application, you can see the number of deployments. You can kill a specific deployment or all the deployments. It's a nice, handy little utility to help you not overrun your resources. Now, you cannot download this and just let Microsoft notify you, which you'll get an email. Microsoft will send you an email to the Live ID that you registered your subscription with when you reach 75% and 100%. And then if you've gone over, it'll also notify you that, hey, you've gone over, and at 125%, it'll notify you. But it only works for committed hours, not for the pay as you grow hours, right? So you'll get a nice little email that looks like this and says, hey, you've got 52 compute hours. You're either going over, you're at 75%, things like that. So you'll get a nice little email. You'll get this anyway, but the gray box application is a nice little way to be proactive instead of reactive. Now let's jump back real quick and let's talk about how VIP swap upgrades work. Because you can upgrade your service by deploying a new package to the staging environment and then swapping the staging and production environments. So again, this type of upgrade is called a virtual IP or VIP swap, and it swaps the addresses. And really all it does is that it swaps the addresses of the two deployments. Now, if you've got multiple instances, these instances are not affected. Really, it's a behind the scene and does not affect anything that's running. The DNS and the load balancer remain intact, and the swap actually happens really fast. So it's almost really unnoticeable. But the key to this is that you can only do this when the service model hasn't changed, meaning have you added some extra endpoints and things like that. So you have to keep these things in mind. Now you can also do this through the Service Management API as well, but so you have several options on how to do these VIP swap upgrades. So how does this work? Let's just show a couple examples. We have one deployment. We have that has a VM role, multiple instances of a VM role, and a couple instances of a worker role. And then in our staging environment, we have the same thing. We have several instances of a web role and several instances of a worker role. And really what happens, you'll notice that all it does is it swaps the load balancer and says, all right, production to staging, staging to production, done. So nothing more than that changes. It doesn't affect your instances, doesn't affect the load balance or anything like that. It just swaps the load balancer and says, hey, production becomes staging and staging becomes production. Done. Now let's talk a little bit about a different type of upgrade, which is called an in-place upgrade. You can perform in-place upgrades on roles that are running in the staging environment or the production environment. So instead of saying, hey, I'm going to swap, I'm just going to perform an in-place upgrade, meaning I don't care about staging. I'm a cowboy. I've got things running in production, so I'm just going to in-place upgrade my production environment. And you can do this as long as the new service model is identical to that of the service that you're currently upgrading, which is fine. Now, it is an IT nirvana, so it's great, but it is difficult to do in a traditional IT, and it does leverage the existing upgrade domains. But again, right, so the service model must be identical, no new roles, no new changes in the service definition files, things like that. And what it does is for each upgrade domain, it stops the instance, updates the instance, and then restarts the instance. So the key to this is how Windows Azure organizes our roles. So Windows Azure organizes instances of our roles into virtual groupings called upgrade domains. Windows Azure upgrades the sets of roles instances according to the upgrade domain to which they belong. So Windows Azure upgrades one domain at a time, stopping the instance, running the upgrade domain, upgrading them, and then bringing them back online, and then moving on to the next domain. So it's a process. Stop it, upgrade it, bring it back online, go on to the next one. Now, by stopping the instances running within the current upgrade domain, Windows Azure ensures that an upgrade takes place with the least possible impact to the running service. So that's why it does it via upgrade domain. It's not upgrading everything at one time, because that'll be an impact to the processing of our instances. So it does it by upgrade domain, and it has the least impact on our services that are running. So how does this work? So we've got our load balancer. We've got our several racks with web roles and worker roles. So in this example, we're taking those offline. We have upgrade domain 1. It's going to upgrade those. Then it's going to go to the second upgrade domain, upgrade those, done. So it's really, that way it's not upgrading everything at one time to protect the performance of our application. It's doing it by upgrade domain to have the least impact on our services. Now there's also a concept called fault domains. Upgrade domains are a fairly known concept in Windows Azure, but fault domains are something that customers have a lot of visibility into, but may need some clarification. So what's a fault domain? Fault domain really represents, it's really a physical unit of failure and is closely related to the physical infrastructure in the data center. So in Windows Azure, a rack can be considered a fault domain, but really there's not a one-to-one mapping between a fault domain and a rack. Windows Azure is responsible to deploy the instances of our application in different fault domains. So right now the Fabric makes sure that your instances, that your application uses at least two fault domains. However, depending on the capacity, the virtual machine availability, it may happen that it spreads across more than that. So right now as a developer, you have no direct control over how many fault domains your applications will use. The way you configure it may impact your availability. So again, the default is 2 and it'll spread those across these fault domains. But let's talk about an upgrade domain. An upgrade domain really is a logical unit. And these logical units determine how particular services will be upgraded. And these upgrade domains are specified by the upgrade domain count specification in the service definition file. The default number of upgrade domains that are configured in your application is 5. However, you can control how many upgrade domains your application can use. So by default it's 5, but you can specify more or less than the default. It's the Fabric's job to split upgrade domains across fault domains and across roles. So this is nothing that you have to do, that you have to program, but because it's the Fabric's job to split these upgrade domains. Let's take a little deeper look at upgrade domains. So really the upgrade domains, like we talked about, are defined in the configuration files, and they are evenly distributed. So let's take a quick look at an example of that. So here we see an example on the top there that in the service definition file, we've got the name, and then we're specifying via the upgrade domain count 3 upgrade domains. And then below in the picture, we can see that we have 3 upgrade domains, so the 3 upgrade domains specified in the configuration file, and how the role instances are evenly spread out and distributed across the fault domains. And this also gives you a good idea of how upgrade domains and fault domains work together. So the next question is how? How do we specify the type of upgrade, whether it's manual or automatic? Now, really these upgrades can be done through the management portal or through the management API. But when we upgrade, we really have 2 options. We have automatic or manual. Now, if you specify automatic, the upgrade process proceeds without further input. So we say go, it goes, no further human interaction. But if we specify manual really says, okay, there's some processes that we need to do, and I'm going to ask you for some questions. So the manual process really means that it's going to make a call to the walk upgrade domain operation, and this is going to initiate the upgrade process requiring some level of human interaction. Your upgrade process really depends on how much control you want over the upgrade process. Now, we've talked a lot about changing the configuration file and how that's done. Let's take a little deeper look at this. There is great flexibility in the way that you can make changes to the configuration file and also what you can change in the configuration file. So first of all, you can change any setting in the configuration files. You just download it, make the change, and re-upload it. And one of the things that you can change, obviously, is the number of instances that are running. And you could really change that several ways. You could change it through the configuration file or really through the management portal, either way. But if we're changing it through the configuration file, well, and there's really 3 approaches to changing the configuration file. And one I just talked about is really editing the portal. It's a quick, easy way to say, here's the configuration, make the change, say the configuration change. The agent will pick up that change and spin up more instances, just like that. The other way is to upload a new file into the portal. So you make the change, upload the portal, and then wait for the agent to pick up and recognize that change. Or you can use the same thing. So you can upload a new file, not through the portal, but through the management API. Now, the great thing about this is, regardless of what you change, and especially if you change the number of instances in the configuration file, By default, changing these number of instances really does not have an effect on the currently running instances. So if you just say, hey, I've got 2 instances, I want to upgrade to 4 instances, that's fine. It won't have an effect on the other 2 running instances. However, if you make any other change, for example, some of the things that we've already talked about in this presentation for like diagnostic changes and the way you want to handle traces, those configuration changes will restart the currently running instances. Now let's change topic a little bit and talk about some deployment and management tools. How can we deploy our applications, and then how can we manage those applications? Now, Microsoft really has provided some great flexibility in terms of the number of options available in which we can deploy and manage our applications. So obviously the first is Visual Studio. We've spent a lot of time in Visual Studio and have illustrated how to deploy and manage our applications. But there are some other options, and as part of the Service Management API, there is a small tool called the CS Manage executable, which, among other things, helps us manage our deployments. Now, Microsoft has also provided a MMC snap-in, and it's called the Azure Management Tool MMC snap-in. And this is simply created to help us manage our hosted services and storage accounts. Now, another method of deployment and management is through a set of PowerShell commandlets. And these are called the Windows Azure Service Management commandlets. So if you're a PowerShell person and like working with PowerShell, this is for you. Now, there are also some third-party products and tools out there. We saw some earlier from Sarah Broadett that allow you to do help with deployment and management. Let's take a look at a couple of these, for example. Right, so let's start with looking at the Windows Azure Service Management commandlets. So the Windows Azure Service Management commandlets are a set of PowerShell commandlets that are really a wrapper around the Windows Azure Management and Diagnostics APIs. The goal of these commandlets is to simply help you develop and test your Azure applications, making it easy to script out your deployments and upgrades. Working with these commandlets is quite easy since they work with the standard .NET CLR. Now, one of the other tools we talked about is the Windows Azure MMC snap-in. This is simply an MMC snap-in that provides a graphical view of your Azure environment and provides the ability to look at your hosted services, your storage services, your blob storage, and even the diagnostics and configuration information. And this snap-in is really built on top of a lot of the Windows Azure Service Management commandlets we talked about earlier. Now, the MMC snap-in is a standard plugin, so it is extensible. And the Windows Azure MMC also allows you to remotely configure your diagnostics and as well download and view your diagnostics information. Lastly, let's talk about autoscaling. Now, by default, when we talk about autoscaling, there are several sections where we've talked about autoscaling, like, for example, Windows Azure Storage. We talked about scaling and how you can scale in SQL Azure and things like that. But when we talk about autoscaling from the Windows Azure side, by default, Windows Azure does not autoscale, meaning it doesn't automatically look at your loads and say, hey, I need to spin up another instance. And the reason for this is because since you're sharing resources with others in the same data center, what is busy for your application really could be different from somebody else's term of busy. So it could be different from somebody else. Now, however, even though it doesn't automatically scale, if you want to scale, you're not out of the water, because Azure does give you the tools to build and develop a scaling solution that is specific to you. Now, this says it's not an easy problem to crack. It's not impossible, but they give you the tools because they want you to be able to develop a scaling solution that is specific and targeted for you. So, for example, there's certain things that you need to take into consideration when you're developing your own scaling solution. For example, there's no defined inputs. You need to define your own rules to determine what's busy or what's not busy. So again, what's busy for you might not be busy for somebody else. You need to make the necessary adjustments in your application to determine how to scale and when to scale. And really, in this last bullet point is obvious, right? Don't run amok. In other words, don't just write the scaling code, throw it up there and let it go, because You want some level of human interaction to say, is this working? Is this working right? Is this scaling the way we want it to scale? So again, don't just throw it up there. Keep an eye on it and monitor it to make sure that it's scaling the way that you want it to scale. In this demo, I'm going to illustrate a number of things that we just got done talking about, meaning we're going to deploy a couple of applications, one to the production environment, one to the staging environment. We're going to do a couple of VIP swaps. We're going to increase the number of instances of some of those on one of those deployments, just to give you an idea and illustrate how easy it is to deploy, to do VIP swaps, to change the instances, and really work within the management portal. So let's begin by creating a new Visual Studio project. I'm going to run this as administrator. And we're just going to create a whole new application. So a new project. We're going to create a cloud project, and we're just going to call this App Dev Hello World. We'll click OK. Again, we're just going to create a standard ASP.NET web role project. Oh, you know what? I forgot to move that over, so we're going to actually do that again. So let's run as administrator. Before I do that, let's just get rid of the one that we just did because we want to name it the same. So let's just get rid of that real quick. 10 projects. Let's delete that one. All right, so we'll create a new project. App Dev Hello World. Click OK. Move that over. We'll just keep that web role 1 for now, just for simplicity reasons. So we're really not going to make a whole lot of changes to this. All we're going to do is go to the design of our default page, and we're just going to drop a label on our form here. Drop a label on our page. And really, let's just set the properties of this to make it easy. Actually, on the load event of this form, let's just say label 1 dot text equals hello world. All right. So there's our application, and we're going to deploy this to the cloud. Before we do that, let's compile. And let's build let's publish this. We're going to create our service package. So there's our service package and our configuration file. And we just kept the default of 1 for the number of instances. We're actually going to change that a little later. So let's go back into our portal. And let's go to our hosted services. And let's create a whole new, brand new hosted service. We're going to say, we're going to click on New Hosted Service. And what we're going to do is we're going to give this a name. We're going to call this App Dev VIP Swap Demo. Let's spell demo right. Make sure that's available for our cloudapp.net. Great. So it is. We're going to choose the North Central US, and we're going to deploy right to production. We're going to call this version 1. Let's go back to our publish, and let's grab the link here, because it'll make it easy to go and get our package file, our service package, and our configuration file. We're not going to add certificates, so let's make sure everything's good. So deploy to production, version 1, start, North Central. Everything's good, so let's click OK. Now, this message and warning basically says, hey, we're deploying a service that only has 1 role. If we look at the details, it says you're deploying a service that only has 1 role. They recommend that you have 2 for performance and scalability, to guarantee the SLA of 99.995% uptime. We don't want that. We're not going to deploy more than one role in this example, so go ahead and just click yes here. Okay, while that's deploying, we're going to mimic the scenario where, okay, we've just deployed our production environment, but now we're working on version 2, and we're going to go back and work on that, and then deploy that. So while this is deploying our version 1, let's go and do version 2. So let's go back to our application, and we're simply going to add something to make a small change to our ASP.NET default page. So what we're going to do is we're actually going to go and drop a button on here. I'm going to move that over here a little bit. And let's just tab over just a tad. And on the click event, we're going to make this change. Let's cut that. There we go. That's version 2. So we just made version 2 of our production application. Okay? So let's build that. Let's run it to make sure that everything runs great. All right, there's our version 2. So we're going to just click button 1. It's going to change that to Hello World. We're good to go. All right, so let's go back to our portal. And while this is still deploying, we can actually say, you know what, we're going to deploy to staging. So we're going to click on our hosted service, and we're actually going to say we want a new deployment to staging. We're going to click on our new staging deployment. We're going to call this version 2. Actually, let's go back here and get the location to our files. Let's grab that, and we'll browse here and go get our service package and our configuration file. And we're all done, so that's version 2. We're deploying to staging right here. Let's click OK. Again, we're going to get the same warning that says, hey, this is only has one instance deployed. That's fine. Go ahead and click yes. Okay, so our version 1 has deployed successfully. Our version 2 has deployed successfully, but realistically, we're going to play pretend here and pretend that our version 1 has been in production for quite some time. People have been using it, and now we're ready to deploy version 2. Before we do that, let's go take a look at some of the information on both of these. So version 1 is our production, version 2 is our staging. So if we look at version 1, there's our DNS name. So just like we named it, appdevvipswapdemo.cloudapp.net. There's our ID. And if we scroll down here, we'll see some important information. There's the version name. But way down at the bottom here is the VIP. There's the virtual IP of version 1. If we go to our version 2, we'll see that there's our VIP for version 2, and all it changed was from 223 to 225, really. There's the 2 VIPs for our 2 applications. So we can actually go in here and launch these. Let's scroll back up real quick and look at our production environment. So there's Hello World. And if we go to our staging, we notice that, like we talked about, there's the DNS name, and the DNS name for the staging is really a deployment ID or a GUID. So it's GUID.cloudapp.net. And just like we did on the production, we can click on that it'll launch, and we can look at our staging environment. And so you can see the GUID up there. Right, so there it is. There's our staging. So we can close that. Now let's do a VIP swap. So we're going to, again, pretend that our version 1 has been in production for quite some time. We're ready to, and we have uploaded our version 2 into staging. We've tested it. Everything's looking good. We now want to swap production and staging. And to do that, it's very simple. We just come up to the toolbar and click on the swap VIP button. And all it says is, hey, we're going to move the bits deployed in staging and production and swap them. And it's very simple, as saying, giving us the information, here's what we're going to swap, and we're going to go from staging to production. And we just click OK. And what it does is it's saying, okay, here, we're just going to update. So all it's really doing here is that it is swapping the addresses of the 2 deployments. So we'll wait a few minutes for it to finish swapping, and then we'll take a look at what it did. Oh, it's already done. So, and as we mentioned before, the VIP swap is actually really quick, so it only took roughly about 15-20 seconds. Now there's version 1 is our staging. So if we click on that, we can launch that and see that, okay, our staging is now what used to be production, and our production used to be what staging is. Right, just like that. So very simple VIP swap, right? So we took staging to production and production to staging. Now we're not done yet, because now let's introduce a whole a little more level of complexity, and let's change our production. And let's say let's change the configuration of our production environment, and let's add an instance. And we talked about the different ways that we could add instances. We could do it through the portal here. We could do it through the API. There's certain ways that we could, there are a number of ways that we could update the instances. But we're just going to, for the sake for argument here, we're just going to do it through the portal. So we're going to select our production, click configure, and here we have several options. We can upload a whole new configuration file, or we can just say, you know what, I want to edit the current configuration, and I'm going to change the count from 1 to 2, and let's click OK. And what that's going to do is that's going to go back, and what's happening is that the agent polar interval is looking to say, yep, has it changed? And yep, I found a change. So you'll notice here in a minute that it's going to create 2 instances. So there we go. We see that it just fired up a whole new instance. It's waiting for the host, and it's updating the deployment for version 2. And in just a minute, we'll see that it's going to be ready to go. Now you'll notice in this instance here that the second instance it has to start up the host, so that's why it's saying, hey, it's only updating the first instance and then starting up the host of the second instance. So if you're updating and it's waiting a long time, you might see this saying, hey, an update is required. Nothing serious, just go ahead and click close, and you'll notice that behind the page, everything's ready to go. It's just going to refresh the page for us here in a second. So we're going to click on our hosted services. Now you notice that everything's ready to go. So we've swapped our staging with production, or actually we've already done the swap. So you notice that version 1 and version 2 ready to go. You notice that our production has now 2 instances, and our staging still has the 1. We're ready to go. So let's take a look at the version 2, our production, and let's go down and look at the VIP. So we're still at 223, so that's good. Now, the question is, can I do a VIP swap now? I've got my staging, because let's continue to play pretend for a second, and after the fact, after we've added the other instance, that management realized that, oh shoot, there's a bug, it's critical. Even though we've added an instance, we need to swap back and address the bug. So the question is, can we VIP swap at this point because we have our staging with one instance and our production with two instances. So let's try that. Let's try the VIP swap and see what happens. Let's go up here and do a VIP swap, and we're going to again VIP swap staging to production. So we'll go ahead and click OK. It's going to start updating, and let's see what happens. So again, our version 1 staging has one instance right now, and our version 2 has two instances. Let's see what we end up with. And let's see if it works. All right, that was a quick VIP swap. So, and here we can see the results. So what happened is that now our production now has one instance, and our staging now has two instances. And this makes sense because all it did is it swapped the addresses of the two deployments. So it makes sense that now our production is going to have one and our staging is going to have two. Now, we talked about earlier that, from the service model perspective, if the service model changes, you can't do a VIP swap. And what that really means is that, yeah, we can do a VIP swap, but only if the service model has not changed between the two deployments. So, for example, if the number of endpoints specified in the services has changed, we can't do a VIP swap. We'd have to do an in-place upgrade at that point. So if the endpoints, or from a service model perspective, nothing has changed, then you can do a VIP swap. But if you have changed something and your service model has changed, for example, you've added some endpoints, then you cannot do a VIP swap. You'd have to do an in-place upgrade. And you can still do that here in this scenario, because we could actually certainly click on, our production deployment here and do an in-place upgrade here as well. And we can do the same thing with our staging and do an upgrade of our staging. So we don't have to do a VIP swap. We can still continue to do an in-place upgrade. But this was just a quick example to illustrate how you can change the instances on the fly through the management portal, how you can deploy to production and staging and do a VIP swap, and the flexibility that gives you for deploying your applications.